this is the question given. We are expected to make the correct choice for this functional value, integral 0 to pi over 4x times f of x dx. So you have the list of choices. Please pause the video, go through the question, work it out, zero in the correct choice. When we come back, let's see what is the correct choice. Okay, I hope you all have got the correct solution. Let us see how to work this question out. Now, this is the solution. We are given f of x is equal to 7 times tan raised to the power of 8x positive 7 times tan raised to the power of 6x negative 3 times tan raised to the power of 4x negative 3 times tan squared x. This is given. I want to rewrite this as 7 times tan raised to the power of 6x times tan squared x positive. I don't want to do anything with all these things. So let me write these things back again. Now we know a formula, secant squared x negative tan squared x is equal to 1. So secant squared x negative 1 is equal to tan squared x. Okay, so this is going to be 7 times tan raised to the power of 6x times, in place of tan squared x I will substitute secant squared x negative 1 and follow it up with other terms. Now I distribute this, I get tan raised to the power of 6x times secant squared x negative 7 times tan raised to the power of 6x positive 7 times tan raised to the power of 6x negative 3 times tan raised to the power of 4x negative 3 times tan squared x. Now negative 7 times tan raised to the power of 6x positive 7 times tan raised to the power of 6x, they get cancelled, giving me 7 times tan raised to the power of 6x times secant squared x negative 3 times tan raised to the power of 4x negative 2 times tan squared x. Okay, now what I wish to do is I want to attack this component now. So 7 times tan raised to the power of 6x times secant squared x negative. I want to rewrite this as tan squared x times tan squared x negative 2 times of tan squared x. This is 7 times of tan squared x, or I mean 7 times tan raised to the power of 6x times secant squared x negative 3 times of tan squared x. I will replace tan squared x as secant squared x negative 1 negative 2 times of tan squared x. This is 7 times of tan raised to the power of 6x times secant squared x negative. I distribute this, I get tan squared x times secant squared x. Negative negative will be positive, right? So let's see. Okay, so this is positive 3 times tan squared x. Now apparently this is actually 3 here, but I've written here as 2, so it should be 3 there. So we have a 3 here and we have a 3 here. So that's going to be negative 3 times tan squared x. Okay, fair enough. So positive negative goes up, giving me 7 times tan raised to the power of 6x times secant squared x negative 3 times tan squared x times secant squared x. So this is what we have got. Now what I wish to do is I will take the secant squared x out. So 7 times tan raised to the power of 6x negative 3 times tan squared x times of secant squared x. So this is what we have got. Now the requirement is integral 0 to pi over 4x times f of x dx. This component is simplified as to represent our f of x. So this is actually our f of x. So hence integral 0 to pi over 4 x times f of x dx is equal to integral 0 to pi over 4 x times of 7 times tan raised to the power of 6x negative 3 times tan squared x times secant squared x dx. Okay, so we have to integrate this. Now I have to go to a new page. We will be utilizing the concept of Lie. So algebraic function comes first, so I'm going to take u is equal to x. So you have du is equal to dx and dv is equal to the next component 7 times tan raised to the power of 6x negative 3 times tan squared x times secant squared x dx. Now we need to integrate this, right, to get the v value. So 7 times of tan raised to the power of 6x negative 3 times tan squared x times secant squared x times dx. So let me take, let there be integral operator operating on both the left and the right. So let me take tan x is equal to t. I differentiate this, I get secant squared x dx is equal to dt. So this is integral 7 times t raised to the power of 6 negative 3 times t raised to the power of 2 times secant squared x dx is dt. I integrate this, I get t raised to the power of 7 divided by 7 negative 3 times t raised to the power of 3 over 3, which is equal to, apparently our 2 7s, they can get cancelled, giving us t tan raised to the power of 7 x negative 3 gets cancelled times, or I would say followed by negative 3 times 3 gets cancelled, so it's going to be tan raised to the power of 3x. So this is what our v is. So uv negative integral v du. So my u is already obtained, so which is going to be x here, right? So x times of v is tan raised to the power of 7x negative tan raised to the power of 3x. Now the limits are 0 to pi over 4, negative 0 to pi over 4, v is tan raised to the power of 7x negative tan raised to the power of 3x times du is going to be dx. So we will have to integrate this. The question is, how are we going to integrate this one? This one is simple, but we have the other component which we have to deal with. So if we were to apply the upper limit and evaluate, this is going to be 0, and the lower limit also will produce a 0. So all that we are left with to integrate, integral with a negative sign, 0 to pi over 4 tan raised to the power of 7x negative tan raised to the power of 3x times the dx. So what I wish to do is, I would like to take tan raised to the power of 3x out and rewrite this as tan raised to the power of 4x negative 1 times dx. Now I have a formula which is written as follows: a squared negative b squared can be rewritten as a negative b times a positive b. So tan raised to the power of 4x negative 1 can be rewritten as tan squared x raised to the power of 2 negative 1. So this is of the form a squared negative b squared. So I can rewrite this as tan squared x negative 1 times tan squared x positive 1. Okay. So this is rewritten as a negative integral. Of course, you have 0 to pi over 4, 0 to pi over 4, tan raised to the power of 3x times tan squared x negative 1 times tan squared x positive 1 times dx. But we know that secant squared x negative tan squared x is equal to 1, and secant squared x is equal to 1 positive tan squared x. We already have tan squared x positive 1, so this is equal to negative integral 0 to pi over 4 tan raised to the power of 3x times tan squared x negative 1 times tan squared x positive 1 is going to be secant squared x. There's already a dx there. Now let me take tan x to be equal to t. I differentiate, I get secant squared x dx is equal to dt. Don't bother about the limits, just make the substitution. So in place of tan you have t, that's t cubed. In place of tan you have t, that's t squared. In place of secant squared x dx you have dt. This is rewritten as integral t cubed into t to the power of 2, that's t power 5. T cubed into 1 is t times dt. So you integrate this. So let me go to the next case. So what we got integral t raised to the power of 5 negative, this is t raised to the power of 3 actually, right? So followed by t raised to the power of 3 times dt. Okay, so let me make the check one more time. Okay, so fair enough, right? Okay, are you watching it? Alright, so this is equal to, I can rewrite this as integral t power 5 times dt negative integral t to the power of 3 times dt. So this is equal to t power 5 integration is t power 6 over 6, t power 4 over 4. But my t is nothing but tan x. So this is going to be negative of tan raised to the power of 6x over 6, negative tan raised to the power of 4x over 4. The limits of 0 to pi over 4. So this is going to be negative. You substitute the upper limit. This is tan 45, so you get 1 over 6, similarly followed by 1 over 4. So if I were to take the LCM as 24, 6 divides 24 4 times, 4 divides 24 6 times. So this is going to be equal to negative 4 negative 6 is going to be negative 2 over 24, which is going to be equal to positive 2 over 24. But 2 divides 24 12 times, right? So what you have found out, so this means integral 0 to pi over 4 of x times f of x dx is equal to 1 over 12. So this should be your choice in making the selection. So this is a lovely question. Okay.